Everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 2, Lesson 12, Estimating Digits in a Quotient. The goal of this lesson today is basically to show where estimation can be useful, and obviously when we say quotient, we are talking about a division problem. So let's go through a few examples together. Okay, let's take this example. It's a fairly simple example. 150 divided by 30. Now, one way we can look at this is 15 tens divided by 3 tens. And as we've talked before, we know we can cancel those out. We end up with 15 divided by 3, which gives us 5. Same thing up here. Go back to this original problem. 150 divided by 30. There's a 0 in the tens place in both. We can cancel those out. 15 divided by 3 gives us 5. If I were to write that out and use the standard algorithm, it would work the same way. 30 does not go into 1. 30 does not go into 15. 30 does go into 150 5 times. 5 times 30 is 150. Subtract, we get 0. Answer's 5. Different ways of getting there, but showing some shortcuts as well. Now, this may seem fairly simple and straightforward, but this type of shortcut, particularly thinking of the 15 tens and the 3 tens, or eliminating those two zeros, canceling them out, going to 5, helps us to estimate. So let's look at another example. Okay, 26,897 divided by 38. Now, in this example, I'm going to say that it is okay to estimate. All right? Now, when we look at estimation, that helps us get close to what the answer would be. It doesn't mean that it necessarily is the answer. And so in a problem like this, if the situation, or whether it's an assignment or real world situation or whatever it may be, if it demands that you have an actual answer, well, in that case, you would have to, whatever method you want to use, but you would have to actually divide out. You'd probably write a lot of numbers down. More likely, you'd actually grab a calculator, but you'd end up with the exact answer. If it's okay to estimate, though, let's look into that. Okay, 38. If I'm going to round that, I'm obviously going to go to my nearest 10. This is my tens place. The 8 tells the 3 to go up, so we end up with 40. 38 is close to 40. Now, before I round this, I'm not necessarily going to round it to the nearest 10,000s place, or the nearest thousands place. What I want to do is make a compatible number. Meaning, if I look at 40 and I just think of 4, and then I look over here and I just think of 26, what number does 4 go into equally that is close to 26? Now, depending on whether you wanted to round up or round down, you know that 4 times 6 is 24, 4 times 7 is 28. So since we already rounded this one up, I'm going to round this one down and see if we can split the difference a little bit. And I'm going to round that 26 to 24, and I'm going to convert all of these other numbers into zeros. Now, the reason I've done that, I'm going to eliminate that so we have a little bit of room to work here. The reason I've done that is because I'm trying to find compatible numbers that will make it really easy to solve the problem. And in this case, I think we've done that. So you may think, well, 40 doesn't go into 2, it doesn't go into 24, it does go into 240, and you could do it that way. You could do kind of the standard mathematical algorithm, right? And you'd still get an answer, which would not be the exact answer, but it would be an estimate. And so, but what I'm going to do is this. Since I have a number that ends in 0 in both of these cases, a 0 in the ones place, I'm going to go ahead and cancel out that 0, and I'm going to cancel out this 0. And even if you're working on paper, I think it does help to have some crayons or markers or pens or whatever handy so you can use different colors. But now that I've canceled out these two zeros, I have 4 and I have 24. And I know that 4 goes into 24 6 times evenly, 6 times 4. Here I still have two zeros left. I'm going to bring those two up. and I'm going to end up with 600. 600 is a pretty good estimate. And I'll be honest, I'm not going to calculate this. I'm going to use I'm not going to do the math on paper. I'm going to actually calculate this with a calculator. If I actually do this problem, I'm going to end up with 707.82. I actually end up with 707 and or I should say 707.815789. I went ahead and rounded. Now, does this make this a good estimate? Is that a good estimate? I would say it is pretty good. Pretty good. Pretty good. It's fairly accurate. It's not spot on. It is in the same place value though, right? This one is in the hundreds. This one is also in the hundreds, and of course with a little bit of change. So it's fairly accurate. And again, when you estimate, you know you're not going to get an actual answer. That's not what we use estimation for. We want to be in the ballpark and get close. If we had to have the exact answer, then we would calculate and we would get this. But by estimating, we're getting ourselves into the ballpark. We're getting close. Okay, we'll do another example here. We have 2,970 divided by 11. Now, this problem, if I were to write it out, 2,970 divided by 11, that looks to me to be the kind of problem that I like to call a pain in the tuchus, right? That does not look like a fun problem to do. Not that we can't do it. We sure could. We could get the answer. We could round it to the nearest, let's say, 10th or 100th, whatever we wanted to do, and get our correct answer. But if we can estimate, and sometimes you can't, but if this is a situation where we could estimate, I'm going to look at rounding this 11 to the nearest 10, which would be 10, right? This is the 10's place value. This is a 0, 1, 2, 3, or 4. So then this stays the same. So we end up with 11 is close to 10. And here, again, I'm not necessarily looking for rounding it to the nearest 100 or rounding it to the nearest 10. I'm looking for what's going to make it compatible. And if we're looking at 10, and here I'm looking at 29, I'm going to say, well, 30 is pretty compatible, and bring these two down both as zeros. So instead of 2,970, I'm going to say 3,000. So in this case, switching colors here so we can see this a little bit better, I'm going to cancel out a 0 on both sides. I know 1 goes into 3 times. I've got these two zeros to move up, and my answer then is 300 for my estimate. If I were to actually solve this problem, the actual answer is 270. So in this case, I would say it was a very good estimate, right? Meaning it wasn't just the right place value, but it was a very close answer. It was very close to the actual answer. So I would call that a good estimate. We'll do one more quick example here. This is a skill. I know this seems fairly easy, or hopefully it feels fairly intuitive, and that's a good thing. But we're going to build on this. So this is not the only thing we're going to do with this skill, but I think this will help you going forward with some of the division problems or division equations that we'll look at. So next problem is 40,644 divided by 18. Now, 40,000 is already a pretty easy number to play with. So I'm going to keep that 40,000 the same. I'm going to make these all into zeros, and I have 40,000. Now, the reason I can do that is if I'm looking at 4 or 40, and I'm looking at 18, I'm thinking, well, 18 is pretty close to 20, and 20 goes into 40 evenly, so I'm going to turn that 18 into 20. I'm going to round it to the nearest 10. So here we go once again, taking off a 0 from each side. 2 goes into 4 2 times. I'm bringing up each 0. So my answer is 2,000. If I use a calculator and I actually see what the total would be, then I would get 2,258. Place value is the same, right? This is in the thousands, this is in the thousands. So I would say this is also a good estimate. Okay, we're going to actually look at these a little bit more in depth together, and we're going to continue to build on this going forward. So thank you for watching.